I've often said the easiest way to learn soldering, or the only real way to learn soldering, is to just start soldering and, get a kit from eBay or something like that. And you can get these little multi-vibrator kits, LED flasher kits, from eBay quite cheaply. In this case, I got a pack of 10 for $5.80, including shipping. And they're described as 10 pieces DIY kit, 5mm LED, simple flashlight, simple flash circuit, and they always use this word suite for kits. I'm not sure why, SUITE. This particular set came from ASP_E-Zone. And the other thing I got, because it comes with 2 wires, let me show you those wires in fact. They're the sort of wires you'd expect to find with the sort of Arduino type kits. So you get wires, just whatever colours they had at the time, with the pins at one end and the socket at the other end, and it's not really ideal for connecting, up to the circuit board for trying it out. So I got the battery holders, and I got 10 battery holders because I've got 10 kits. It was only about $5.75. And these ones came from Love Cell 2013. Oh, that's a nice, memorable name. But again, I'll provide a link down below in the description, just showing, to a common search on eBay for this type of thing. And I have to say, the battery holders that came are quite chunky. They're actually quite good quality. They feel very robust. It's quite nice. So here's the circuit. It's got two 33k resistors for timing, two 22 microfarad capacitors for timing. It's got the 510 ohm resistors in series with the LEDs, and then 2 transistors. And the nature of the circuit is such that initially when you power it up, one of those transistors will take preference over the other, and it will turn on. And when it does, it will turn on the LED, but it will also effectively keep the other transistor turned off. And then a little time delay based on these resistors here in the capacitor will occur, and then that transistor will turn on, and it will turn that transistor off. So basically speaking, it just toggles backwards and forwards. It's a very, very popular circuit, very simple and very gratifying. My first ever circuit was one of those that actually, but modified so it could flash a tungsten lamp very, very brightly, like a strobe. And I screwed it up. I never got it working. It was my first ever kit. I absolutely smoked one of the transistors, I think. Oh well, that happens. This is why I say buy more than one. So the resistors, the 510 ohm is green, brown, brown. That's 5, 1 and 1, 0. And the 33k is orange, orange, orange. That's nice, easy to remember. 3, 3 and 3 zeros. And two of the components, well, the transistors are polarised, but it'll be obvious, but the ones that can be put in the wrong way around are the LEDs and the capacitors. So I'll just mention that when I'm actually doing it. However, to make things extra beginnerish, I'm actually using a cheap soldering iron this time from CPC in the UK. This is from an electronics supplier in the UK. It is rated about 25 watts. It's thermally balanced, which means it just goes up to a balanced temperature, and in this case it's about 460 degrees Celsius. It's quite high, as you can see from the discoloration. So it definitely requires a bit of cleaning and tinning on a frequent basis. But I just decided, let's get one of these cheap irons and try it. I have checked, because it's from a British supplier, a reputable British supplier, it is grounded. And the bits for this are quite cheap. They're only about £1 or so each for the replacement bits. When you power this soldering iron for the first time, it will emit a lot of smoke. Don't worry about that. That is because it uses mica as an insulator. And the mica during manufacture, because mica is loose sort of glass-like flakes, during manufacture, to keep it together, they put a sort of plasticizing agent in it. And it's just basically a binding agent. And that makes it into a flexible form that they can then wrap it around the core, wind the heating element around it, wrap another layer around, and then wrap wire around it to actually secure it in place. And then when you heat it up, all the binder burns out, and it leaves the layer of insulating material on its own. So the stand was this soldering iron was about £4 or something like that. It wasn't that expensive, plus VAT, value added tax. Well, just another government tax. The stand was only about 2 or 3 quid or something like that. It's quite cheap. Now, it's worth mentioning that when this one arrived, This little brass thing here was sitting in it like that. I don't know if it just, that's the way it had been put in, or if it had been really rammed in the shipping because it had a dent in it. But when you try clean the iron in it, it just bounces about in there. It's no good. So if you get one like that and you want to actually put it in the correct place, just take the brass wool out and just lift that up, slide it in until it clicks down, and that will lock it in place, and then you can put the brass cleaning pad in again. This is the alternative that's very common these days compared to the wet sponge that used to be used to clean soldering iron bits, and it's quite effective. It's low maintenance. You don't have to keep topping up with water, or that situation that in a long soldering session you'll get the smell of burning sponge because it's dried out. This one, it stays fresh, and it's quite good at scraping off crud, which is quite useful because this does get quite hot. So here's the kit, and I'm going to zoom in for this so we can actually see it in greater detail as I assemble it. So I've got just a short piece of solder. It's not going to take much solder for this. And I'm going to zoom in now. So let's go right in here. I'm going to start with the two 510 ohm resistors, said Clive. It suddenly realised that he was well off shot there. That's okay, I'll do my best to stay in shot here. So let's, if it comes to it, I'll just zoom out a wee bit, but you know, I'd rather add a bit more detail here so you can see what's going on. So let's put the first of the 510 ohm resistors in. I'll put both the 510 ohm resistors in. Like this. They haven't really allowed much room, so you have to bend the leads right up against the body of the component. So let's solder those right now. So this is where you could use a bit of tape over the back, or as Julian Eilert shows, oh look, I pronounced Julian's name correct this time, that's good. Julian Eilert, he uses the blue tack underneath, which seems to be a common approach too. So let's tin this tip, make sure the tip's nice and clean and wetted with solder, and then just apply it to those those pads, and you're placing the soldering iron onto the pad at the same time as you apply the solder. So the solder is going onto a hot pad and component. You touch both the pad and the component with the tip of the iron. That looks pretty good. Tell you what, for extra economy lessons in soldering, let's use, these just arrived, let's use generic cheap eBay snips as well. So you could really get started for probably less than 20 quid complete, including several kits. So that's those two resistors in. Let's now stick the two 333k resistors in. And all the components are marked on the board, so I'm actually just, although the resistors aren't polarized, I'm putting them in the same direction as you'd read the color code on them, just because. So let's fold those leads down and pop them in. Right, and I shall solder those now. So where's the solder? Straighten those leads up a bit. I prefer the leads to be straight up when I'm soldering. Not super critical, but you know, I just prefer it that way. Solder that one and solder that pad. And I'll solder that pad and that pad. How's that showing up? Is it showing up okay? I think it is. Because it's so easy to go off frame when I'm zoomed so far in, I've made a little black dot right in the middle. So that's just my reminder to try and stay in that area because it's so easy to drift out. Literally, the area that I'm filming in here is just, you know, it's tiny. It's just about 2 inches when it's zoomed right in like that. So the next thing I'm going to put in is the transistors, and the transistors are 9014s, and you'll notice the body of the transistor is curved, and there's a curved image on the actual circuit board. So we want to align them up like that and just sort of spread the leads and just pop it in and make sure that transistor is the right way around. If the transistor is not the right way around, it will not work. So let's put the other one in at the same time. And both of them have the flat side facing in towards the middle of the circuit board. I'm just going to wiggle them down, make sure they're roughly straight. And don't be too bothered. If you solder a component and it's squint, don't panic about it too much. You know, it's really not that. It's not going to affect the operation. Just the appearance slightly. But hopefully I'll be looking at the wonderful blinking LEDs and not your quality of your soldering and component placement. Okay, so I've soldered the two middle leads of those transistors. And the transistors are looking fairly square. So I shall solder the other leads. Now, the transistors are easy to damage. Well, they're much less easy to damage now than they used to be. But I wouldn't linger too long with the soldering iron on them, just as precaution. These are very standard transistors, so you could easily get replacements. So let's solder that, and I'll switch over to the other side and solder that one, just to allow this one to cool back down a wee bit. Then solder that one. And that one. This is actually where the very fine tip of this actually is quite useful for going in. It's a usable iron. You know, so far I've already done a practice board, and it went together very well. And initially I found that iron just a wee bit clumsy because I'm used to my somewhat slinkier little low voltage one. But having said that, it's fine. This chunky iron's quite fine. It's certainly doing the job. Although having said that, we'll wait till and see if it works before we make our judgment. Now, the LEDs have a long lead and a short lead. The long lead is a positive, and the symbol for the LED shows the diode pointing from positive to negative effectively. Some people will disagree with my description of that, but you know what? The long lead basically goes in the opposite end to the bar, and the short lead goes to the end of the bar. Discussing electron theory and direction of current flow is always a can of worms with the pedantic people. I'll cover that in a later video. I've just not quite finalised another video about electron theory. And there's an annoying thing that, you know, it literally is, electron theory is a theory. So here's the positive, the long lead going in that end of the diode symbol here. And unfortunately, right at the beginning, they thought electricity flowed from positive to negative. But in reality, the electrons flow from negative to positive. But it doesn't really matter, because the only people who are really bothered about stuff like that are scientists who are manipulating electrons. To you and me, it doesn't really matter what direction it flows. And in the case of AC, it doesn't matter at all, because it's flowing in both directions simultaneously, well, alternately. So I've soldered those two leads. I've checked that the LEDs are straight. If they hadn't been straight, I might have nudged them down a bit. But again, if this is your first kit and the LED's a wee bit squint, it doesn't matter. It's just one of these things, you know, practice makes perfect. That's another thing I've always said, you know, it's like the only way to get good at soldering is to solder. The more you solder, the better you get, because you just get the feel for it. And a lot of it is down to feel. So let's crop those leads. And now that leaves the capacitors. The capacitors are also polarised. They have a long lead at the positive and a short lead at the negative, and they also have this stripy pattern going down on the negative side. And the negative side is also marked. Well, there's a plus symbol here, plus there's a sort of whole checkered area, which is the negative, and that's where the sort of stripe side will go to. So I'm just going to put one of those in and solder it. And it's holding in itself by friction in this instance. Famous last words, because as soon as I touch it, it'll probably just fall out. So that's me soldered one lead, and I'm just going to check it straight. It looks straight enough to me. That's fine. The solder I'm using here is common generic lead-based solder. It's the lead tin mix, or should I say the tin lead mix. Since I think it's called 60-40, and I think it's 60% tin and 40% lead. Plus, the most important bit, it's got flux down the middle of it. If you use a solder that does not have flux down the middle of it, it's just hellish to solder with. because the flux is needed to mate the solder onto the metal. It has a sort of cleaning and mating effect. It just results in much better joint. Without the flux, it will just maybe sit on that metal and not really flow onto it. So once again, the capacitor has this stripy mark, the negative end, going towards that sort of checkered area of the symbol. Checkered or hatched or whatever, yeah. And I have to say at this point, these are a bit close. So don't worry if they don't seem to fit too well. It's absolutely fine. It's going to be fine. So let's solder this. And crop the leads. Looking good. Now I'm going to solder in the battery leads, because these things, yeah, you could put these in, but then you'd have to cut the other ends off and then hook them up to a battery or power supply. I just think the little battery holder is just a neater solution. So here's another oddity that's really not very helpful for beginner's kit. Ground. That means that's the negative. Ground is the negative. VCC is the positive. VCC basically stands for collector, voltage of the collector, which is to do with these transistors. They could have just said positive. It would have been so much nicer. So ground is the negative and VCC is the positive. So let's solder the ground lead in first. So I'm just holding it through there and just flowing with some solder on it. And then we'll flow the positive one into the VCC connection. This is where, when you're trying to get everything positioned, the wire may pop out. It doesn't matter if it does, just realign it. And that should theoretically be the kit complete. Shall we give it a test? Shall we see if it works, or just goes pop, or nothing happens at all? So I'm going to pop a couple of batteries in and turn it on, and there it goes. So you could change the speed of that. I think you could change the speed partly by using a higher voltage, because the 3 volts is very close to the blue LEDs anyway. So I think with a higher voltage it would slow down, but you could also, the 33K resistors in there, you could use a higher value to get the slower flashing as well. Or you could increase the value of the capacitors, although there's not a lot of room in there. So yeah, you know what, those kits, I'm just going to zoom back out again, just in case it causes nausea. They're great little kits, very simple. This soldering iron is completely usable. And it's cheap. It's a cheap way in and a safe way in, because it is, well, this is a genuine CE logo, because this one is from a UK supplier, and it's the sort of Duratool brand. But yeah, and the soldering iron stand, it's nice and robust. Yeah, that's pretty good. I'm not sure what the equivalent to that would be in America, or I think CPC Farnell are based all around Europe, so that's Europe sorted. But the American ones, I get the feeling that because it's 120 volts, you may find they just tend to have the 2-pin plug on them, like those cheapy Chinese ones that I wasn't too impressed with the construction quality of. But yeah, simple kits to build, and just a great way to learn to solder. A little extra bit for this video: what to do if your kit doesn't work. The primary suspects for kits not working are wrong component positions or bad soldering, and they're all easy enough to actually diagnose. So the first thing you should do, and this is where it's useful to have several of these kits, because then you can look at the circuit board from another one. The first thing to do is check that the resistors are the correct value in the right positions, and that the components are the right way around. It's easy, probably the easiest to get in the wrong way around might be the LEDs. And if you look through the LEDs from the side, this isn't always the case, but it's quite often the case. The anvil-shaped reflector inside it is usually the negative, and the little electrode that comes up the side is the positive, and then there's a wee sort of gold wire inside that jumps onto the emitter. You can also look at the base of the LED. Sometimes there's a flat at the negative side of the LED. The transistors, if they're the wrong way around, it won't work. The capacitors, it probably would work if they were put in the wrong way around, but it's not recommended. So you can check that the mark on the case, the little sort of negative symbol, the stripe, they're both, in this case, on this particular kit, pointing in towards the middle, or whichever way it shows on whatever kit you do. If you look at the soldering, ideally, if that's a circuit board and you've got a component lead coming through it, the solder should flow up like that in a sort of little volcano shape, and it should just mate onto the metal. If it doesn't stick properly, the telltale sign is that you end up with something that looks like a blob with the component lead sticking out the top. And if you were to cut that in half, it would actually look kind of apple-shaped. And that suggests that the solder hasn't stuck on properly. It's still possible to get a blob if you put too much solder on and still get a good connection. But another clue is if it looks all mottled and frosty, that may suggest that, you know, the flux had evaporated. One of the most common mistakes in soldering is people trying to carry solder across to the component by putting solder on it and then trying to wipe it off onto the pad. That does not work. The only way to put solder onto that pad, if this is the pad, and that's the lead coming through it, the only way to actually apply the solder is to put the soldering iron so it touches both the pad and the component lead, and then flow the solder into it. Because at the point you flow the solder in, that's when those little wisps of fumes come out, and it's actually the flux evaporating from the middle of the core, and that's the bit that encourages it to mate together. Another slight possibility might be that you have a bridged solder joint. That's easy enough to find. If you look at all the solder connections that are next to each other, you might find that there's a tiny little bridge of solder, and it can be super thin. It could just be a tiny whisker going across. If you get that, the best way to actually fix that is just get the soldering iron and just flick it. You know, and that should just, hopefully, the heat of the soldering iron should remelt the solder and it should flick it clear. That's the easiest fix for that. And once you've done that, if everything looks like it's in the right place, if the soldering looks good, if there's no bridges, and the battery polarity is correct, and it still doesn't work, then make another kit. You know, that's why you got several kits in the first place, is just because as a contingency plan that, you know, you might have done something wrong. And usually the second time round your kit will work. If it doesn't, just reassess it carefully again and have another go. That's why you've got several kits. And eventually you'll just get the hang of it. And soldering just, you know, as I say, it's one of these things that just comes naturally. The more you do it, the easier it gets and the better your soldering looks. So that's basic kits.